Hi, welcome back to Key Concepts in Technology. And today we're having a follow-up to our presentation on computational thinking with one of my great colleagues in the Communication, Culture, and Technology program, Evan Barba. Evan, you've got a great background in computation, human cognition, and the design of tangible artifacts. How would you explain computational thinking to someone who doesn't have a computer or technical background but wants to understand the core principles of computing for better engagement with technology today?
So I can see two very different ways of thinking about computational thinking. One is really more practical, and one is more of a philosophical or existential question. So on the practical note, there's this idea that we live in a world that is full of machines right now, and we need to understand the way that those machines do things so that we can predict their behaviors, so that we can use them effectively, so that we can organize and structure our environments and information to make them computable. And so that's one very, very practical approach towards computational thinking. A second approach might be thinking of the human capacities of thought and cognition as being computational themselves. And this is really a philosophical question because it gets into all of these questions about what the difference is between the stuff that goes on in our heads and the stuff that goes on outside in the world, what those boundaries are, which of them can be represented digitally without losing anything important, which of them are purely analog processes, and what that kind of continuity that's implied by those analog processes actually means. It's a whole metaphysical can of worms that we're opening up by talking about it that way.
And it's still open to huge debate in terms of how that's going to fall, right? And you know, one of the motivations for our course is helping people with non-technical backgrounds go beyond this, this kind of machine-human division that we see all over, this kind of techno-determinism that's always creating these, dystopian scenarios, even of Skynet and Terminator and things like that, right? But what I'm fascinated by is this other fields within cognitive science that are revealing how computation is both an artifact of and an aid to human cognition. And I know that's something you've thought about a lot and are really involved in. How do you see what's involved in computing being connected to core human capabilities and needs, in thinking and learning and creativity?
So I think we need to be a little bit careful here. I think, as I mentioned earlier, so there is this kind of divide between what we consider to be the kind of digital world of the computer and the really the analog world that we kind of inhabit naturally on a day-to-day basis. And I think there's something of a false dichotomy there, because when you think about the way that the human brain actually works, sometimes there are things that are represented digitally, and sometimes there are things that are represented as analog and continuous signals. And all of those things kind of work together to result in what we consider to be human thought, human thinking, human cognition. And so I think that we're kind of applying these words to things and the concepts that come along with them, the discretized digital world and the kind of continuous analog world. But I think the reality is actually probably that those two things are really just the same thing, thought about and conceived of differently and measured differently. And so when I think about human learning and human capacities, like the creativity, for example, I'm starting more and more to think of them in terms of networks, to think about the way that the networks in my head, the neural networks that exist in there, are representing things outside in the world through the inputs that I get from my senses, and the way that those things kind of are both discretized in the sense that I'm pulling apart concepts and categorizing them constantly, but I'm also getting this continuous stream of sensory information. And I'm putting those two things together in order to make meaningful judgments about the world around me. So I think that if we're going to really try and interrogate this idea of how computational thinking and human capacities are related to each other, we really need to be thinking beyond this digital analog divide and start looking at things as networks which sometimes take one topology or another and arise from our interactions with everything around us, right? It's Heidegger's being in the world again,
Yeah,
right?
yeah, right, sure. I mean, I'm all for getting rid of all the old dichotomies that we have to live with. So from your point of view then, do you see our ability to model computationally, a lot of cognitive and perceptive processes? Do you see this as one of the ways of opening up what computation can do to people who aren't necessarily technical or have a computer science background?
So I think that's an interesting question because so maybe it kind of goes back to the more practical definition of computational thinking that I gave you. Because if you want people to really understand what these really complicated algorithms are doing, if they want to understand how Google search is working or how their data is being mined by Target or Nielsen, they really need to start thinking about the algorithms that are applied and the data that they're being applied to. Our being in the world these days is essentially creating data for machines to crunch on. We're simply going about our daily business and interfacing with technology and machines on a near constant basis. That's a really profound change that's happened in the past 10 years, and it's clear to me that not everyone has quite caught up to what's going on in that way.
Sure.
So one of the things that I hope your course does is that it gives people the conceptual tools to think about these processes that are happening all around us and their own complicity in those processes.
Yeah. I mean, that's what we hope. That's what we hope to do. I mean, as we keep emphasizing in CCT and in my course, that computational thinking and what computation is about should really be learned by everyone who has any engagement with the world and any profession. The more you know, the more it's going to open up opportunities for you to really be active and engage in your field, because computation touches every field today, right? I mean, name a field that it doesn't touch, right? It's really important. Another topic that I know is really important to you is the relationship between computational thinking and actually doing computing. My friend and colleague Peter Denning in ACM, had a great article where he was talking about the difference between computational thinking and computational doing. Computational doing gets, really complex and down in the weeds of writing good code and programs and algorithms. I mean, that's what computational doing is all about. But it seems like you're in an interface between a lot of these really interesting activities, especially your interest in design principles and design concepts, and where computation, design come together in the design of tangible things, right? And producing actual tangible material artifacts that are a product of both kinds of thinking. Could you talk about how computation design come together for you?
Sure. So I'm starting to develop some very strong feelings about this because I feel like there is a trend in academia, but really it's being driven by the mainstream. But what I think has happened is that we now have all of these really simple consumer-grade computational tools, and people have started, in mass now to create digital artifacts with these things. And there is, I think, a tendency to look at this as something that's very new. And in some ways it is, because as I said, we now have these really cheap technologies that are readily available, and there's huge databases of users making amazing and interesting
projects. Anyone with a tablet can have a little app that can edit music or photos or video.
That's right.
Sure, yeah.
And so it's become much easier for us to become producers of these digital artifacts. But I think that really the meaningful processes and practices that go into creating tangible artifacts are the same ones that have existed for all of time, right? I mean, it's not very different than when a sculptor makes a statue or when a painter paints a painting. These are all ways that we use tools to create and express ourselves and to build the things that we want to see in the environment around us, right? We're constantly externalizing our thinking into these artifacts. The fact that we have computational tools, digital tools to do that with now is interesting. It changes the kinds of things we can make, but it doesn't change the core of that process, which is essentially an iterative one. It's one where you create something from your mind, put it into some medium, you experience what it's like through all your physical senses, which you can't really do when it's an abstraction, and you reflect on what's working about that, what you want to revise about that, and then you go through that process again until it gets to be the way that you want it to be. that process is completely and totally independent of the medium that
Yeah.
you're working in, and it has never changed. And so I get really frustrated when people are trying to say that that everything that's going on in making and the maker movements is something that is really new, because there's parts of it that are, but really the core of it is not any different. And when we try and hope to get new things out of education by incorporating this stuff in there, we have to recognize that it's not because that we're adding something new to education. It's because there's something that was in education that was missing that we only now are recognizing and giving a name to, and being and able to put that into a curriculum in a very real way.
Yeah.
But it was always there. We were
Right.
we were just blind to it.
Yeah.
And now, for some reason, now that we have computational tools, we think it's the new rage.
Right, or that it's all an effect of being digital, or it's all an effect of
That's
having
right.
computation,
That's right,
as
yeah.
opposed to these were core human functions that we've been mediating and remediating technically for centuries. And this is our latest, greatest one, and it can do cool things, but what we do with it isn't a product of the technology, but it's what it's motivated by the functions that we want to see happen.
I totally agree.
Yeah. This has been great. Well, it's been a great conversation, and I know many of our students are going to want to follow up on a lot of the ideas that we talked about today. And thanks for joining us for this great conversation with Evan Barba, and we'll be seeing you again soon.